So this is the questions for lecture number 7. Let's start the solution discussion on that. See, bromination you have to done, and we have a substituent, we have this alkyl group. Okay, so this is the method for the preparation of aryl alkyl. So here we have two hydrogen. This hydrogen can be easily replaceable. Okay, so we have only one bromine, so we'll go for only one resultant. So here is that result. I'm writing that is one of the bromine will be attached here, and then CH3. Okay, so this is the result of your question, and this is what NO2. And the second question, here we have HCl, here we have OH. Again, it can be substituted very easily. This OH is also, and this OH, so this OH can be substituted very easily. Okay, so here the result will be what? The result will be OH, and this will give you CH2Cl. Okay, so both questions are based on the preparation of aryl alkyl group compounds. Okay, so these are the solution for your question. Thank you so much. So this was the question of lecture number 8, that haloarenes cannot be prepared from phenols, like alkyl halide from alcohols. Okay, just like alkyl halide we can prepare from alcohols, but haloarenes cannot be prepared from phenols. So what is the reason for that? So let's start the solution. See, it is very difficult to replace OH group of phenol by a halo group. Okay, it is difficult to replace OH group of phenol by a halo group. And why? Because of resonance in phenol. Because of resonance in phenol. Phenol is resonance stabilized. Okay, so as we know that this is a phenol. Okay, so this is a phenol compound, and this is what? Phenoxide ion. This is what? Phenoxide ion. Okay, this is called phenoxide ion, and this phenoxide ion is what? Resonance is stabilized. You know that. Okay, this oxygen negative charge, this will go to this side and this will go to this side, so this can be proceed further. So this is what? Resonance stabilized. Okay, and as you can see that as it is resonance stabilized, there is a partial double bond character generate over here. Okay, so here the carbon and oxygen bond is a double bond, partial double bond character here, and this partial double bond character makes this bond stronger. This bond is stronger in what? Arenes. This bond is stronger in arenes. But on the other hand, in alcohol, what will happen? Only we have a single bond here. Here we have a C, H, H and H. So here we have a single bond. So this bond is not stronger. So it is very difficult to break this double bond. Okay, this is very difficult to break this double bond. So cleavage of carbon oxygen double bond in phenol is difficult. Cleavage of carbon double bond oxygen bond in phenol is difficult. So reason is what? Because of the resonance stabilize, this gets a partial double bond character, and it is very difficult to this bond. Okay, so this is the answer of this question. Was somehow very tricky, but it's a good question. Okay, so thank you so much. So this was the question of lecture number 9. Okay, so here let's talk about the reactivity. We have a chlorobenzene. Okay, ortho and para directing, this was the question. Okay, that chlorine is an electron withdrawing group. Okay, there is no doubt about that, electron withdrawing group, yet it is ortho and para directing. So reason is what? And special cases of electrophilic aromatic substitutions. So what happened, this pi electron will attack here, this is the ortho position. Okay, so this is called attack at ortho, attack at ortho position. So this will give you a positive charge here, because the direction of the electron is here. So this will be a positive charge, this is a negative charge, and this is a positive charge. Okay, and chlorine, now we know that this is what? Electron withdrawing group. So this is ortho attack, and what will happen in this case here, the electrophile will attach with this hydrogen. Now as we know that this is a positive charge and this is electron withdrawing group, this is what? This is electron withdrawing group. So what will happen? This will withdraw the electron, and if this withdraw this electron, this certainly destabilize the intermediate carbocation. So reason is what? Inductive effect is there, no doubt. Inductive effect, that means minus I. What? It is destabilize the carbocation, intermediate carbocation. And if it is destabilized, then there is no reason. Similarly, it will go for the para attack also in the same way. Now in the second case, what will happen, if we have second case, that is the chlorine. Okay, and this is again the electrophile, and again we'll go for the, I'm only taking the ortho take, no, you can go for the para take with the same pattern, there is no change. So now what will happen in this case? In this case, this will generate a positive charge, that means the cation. This is the positive charge cation, and this is the Cl. Now the second case is what? If this electron moves to this side, that means the resonance effect dominates here. Okay, let's draw this again, H and E. So if the resonance effect is a dominant here, that means if the resonance effect is works here, not dominant, actually works here, so this will certainly what? This will certainly stabilize the intermediate carbocation. So here is the reason, and here is another reason, is what? The resonance effect. The resonance effect, and that is what? Plus R. Stabilized carbocation. I think this we had already discussed, no? Stabilized carbocation. So it means the resonance effect is stabilizing carbocation and inductive effect is destabilizing carbocation. Okay, but what we know that the inductive effect dominates always over resonance effect. So this theory should be correct, but it is not. This theory is correct. There is a there is a fight between the dominancy of inductive effect and the resonance effect, and due to this we can say that in concluding statement that the reactivity, that means the chlorobenzene reactivity is controlled by what? A stronger inductive effect. A stronger inductive effect. Reactivity. Chlorobenzene will be reactive. We know that the uh, chlorobenzene is a less reactive compound compared to benzene, but its ortho and para directing is there. And orientation is controlled by what? Orientation is controlled by resonance effect. So this is the reason. This you need to write in the final statement. Very important question, very logical question. Okay, you cannot deny the importance of inductive effect. So inductive effect is will be there, orientation resonance effect will be there, but the two things, reactivity is controlled by the inductive effect and the orientation is controlled by the resonance effect. Okay, so this is the explanation of that question. Thank you so much.